Okay, we're in the final third of week 5. We're going to talk about sections 5.1 and 5.2. First, section 5.1. So we're moving into basically some analytic trigonometry at this point. So in section 5.1, we want to understand how to verify trigonometric identities. And in this case, we're just going to use the fundamental trig identities to verify different identities. Okay, so these are examples we're going to end up talking about. And I just want to make sure you understand what they mean when they say what are the fundamental trig identities. So we have what are known as the reciprocal identities. By the way, I don't really care if you remember the names like the reciprocal identities, but you should understand that. Remember, we had cosecant of x is 1 over sine of x. Hopefully everyone is comfortable with that. Secant of x is 1 over cosine of x. Cotangent of x is 1 over tangent of x. So certainly that means that sine x is 1 over cosecant of x. Cosine of x is 1 over secant of x, and tangent of x is 1 over cotangent of x. We also have the quotient identities. We've used the fact that tangent of x is sine of x over cosine of x a few times. Well, also that means that cotangent of x is cosine of x over sine of x. We have the Pythagorean identities. We've seen sine squared x plus cosine squared x equals 1 multiple times. Then we have these other two, like if I multiplied this entire equation by cosine squared x, I would get sine squared x over cosine squared x, which is tangent squared x. Cosine squared x over cosine squared x, which is 1. And 1 over cosine squared x, which is secant squared x. So that's where that one comes from. This guy is evolved from dividing the entire regular Pythagorean identity by sine squared x. So sine squared x over sine squared x is 1. Cosine squared x over sine squared x is cotangent squared x. And 1 over sine squared x is cosecant squared x. And then we know that certain functions are even or odd. We know that the cosine and the secant are both even functions and the other 4 are odd functions. So you should understand the even-odd identities as well. Using all of those, we should be able to verify some basic identities. So in example 1, we say rewrite cosine squared x plus cotangent squared x plus sine squared x. And we want to get that in terms of cosecant of x. So cosine squared x plus cotangent squared x plus sine squared x. First thing I would do is group the cosine squared x and the sine squared x because that's a very simple Pythagorean identity that we know is 1. Then I'm left with cotangent squared x. And then 1 plus cotangent squared x, we should know from our Pythagorean identities that that comes out to be cosecant squared x, right? Right up here, 1 plus cotangent squared x equals cosecant squared x. Okay, so a little bit more complicated. We want to verify 1 over secant x plus tan x plus 1 over secant x minus tangent x equals 2 secant x. Whenever you're asked to verify identities, you should always start with the more complicated side and work towards the more simplified side. So I want to take these two guys on the left, 1 over secant x plus tangent x plus 1 over secant x minus tangent of x, and combine them into one fraction. So you can think of it as cross multiplying if you want, or the common denominator is secant x plus tangent x times secant x minus tangent x. But make sure you combine them into one fraction. Then in the numerator, we get the minus tan x and the tangent x to cancel. Then we have 2 secant x over, when I FOIL this, I get secant squared x minus tangent squared x. But secant squared x is the same as 1 plus tangent squared x, so really the denominator is just 1. So in all, it comes out to be 2 secant x, which was verified what we were looking for. In example 3, we want to verify that sine x is minus cosine of x times tangent of minus x. So again, when we want to verify identity, start with the more complicated side and work towards the less complicated side to show us the same. So we start with minus cosine of x times tangent of minus x. So first of all, whenever you have something that not everything is in terms of sine and cosine, let's get everything in terms of sine and cosine. So minus cosine of x, now we're going to use the quotient identity for tangent. So that's sine of minus x over cosine of minus x. But cosine of minus x, cosine is an even function, so that's the same as cosine x. So those cosines cancel. And I get minus a minus sine x, which is sine x. So it was pretty easy to verify that. In the last example, we want to verify that the sum of these two fractions is equal to minus 4 tangent x secant x. So again, I would call this the more complicated side. We want to combine that into one fraction. We want to work towards this guy equaling this guy. So we're going to combine the left-hand side into one fraction. So again, the common denominator is 1 plus sine x times 1 minus sine x. Think of it as cross multiplying if you want. So it's 1 minus sine x times 1 minus sine x minus 1 plus sine x times 1 plus sine x. FOIL each one of these pieces. You get 1 minus 2 sine x plus sine squared x minus 1 plus 2 sine x plus sine squared x. The 1's cancel and the sine squared x's cancel. And I'm left with minus 2 sine x minus another 2 sine x, or minus 4 sine x. The denominator, when I FOIL it, is 1 minus sine squared x, which we know is cosine squared x from the Pythagorean identity. So I get a sine x over a cosine x, taking one of those cosine x's out, and then I have times 1 over another cosine x. So sine x over cosine x is tangent x, and 1 over cosine x is secant x. So we have worked towards proving that, verifying that identity as well.